So my name is Artem Aliev. I work for company DataStax in an analytic team, and we do analytic for one of the new NoSQL distributed database that called Cassandra. And well, actually, before I start, let me a little bit understand the auditory. Who works with any NoSQL database? Okay, everybody know what is it, and who know what Cassandra is? Oh, well, much better. Who know what is a Hadoop is? Cool. Who use it? Who knows what is Spark is? Oh, okay. Who use it? Well, we got plenty of people who know and use it. Well, actually, Spark will replace MapReduce. And who know what MapReduce is and how to use it? Okay, sure. So I will talk about, agenda. Agenda is really simple. Well, actually, when you build, right now anybody build a data flow, they build something like this. When you get a batch processing layer, when you have data sources on the left, put it into the databases. You have a data lake or something like that on the older thing, the data lake, and you build all the data there, and then you process it by the night and put the data into the serving layer. When you use your BI and show it to the people, it's not a BI. It could be any, I don't know, recommendation engine, your website with a catalog or something like that. And well, actually, the new layer appears that called speed layer or streaming, when you stream data on memory and produce result on a fly. So, well, actually, some guys from the Lambda architecture called Lambda architecture and draw the picture. The other guy says that this data lake is all thing, and you need only the thin layer, the small layer that's called speed layer, and you need to do only speed processing, and this kind of called Kappa architecture. But well, actually, it's a common way to do things, and let's try to build one of that kind of system based on Cassandra. A little bit about Cassandra. Cassandra is a new kind of databases. As any other NoSQL, I think it's scalable. And it's much better scaled than most of the NoSQL system because it's masterless. Everybody nodes are equals. Everybody can be master. And so you can scale it linearly for a long list. And actually, the good feature of the Cassandra is that SQL language that is like SQL. I will show you later. So actually, it's a multi-data center. You can manage replication factor on any data center. So you can have 2 data centers with the same data all over the world. So the data replication is every node in a cluster know how the data layout, how it's sharded. So it's sharded and how replicated. So it's really simple thing to do, to work with. So, and it's really configurable. It's a good way to use it. And my lovely feature of the Cassandra is that kind of language. Well, actually, while a lot of NoSQL system has the ability to scale linearly, have these masterless systems, but SQL language is a feature. Well, actually, Oracle guys like this really well. And actually, the only thing that helped Oracle guys to step into the NoSQL world is to write that kind of lines of code. Well, actually, beside that, it's still wide row, like if you know what this means, database that allow you to add rows on the add column, white column, add column on a go as you go. So what the Spark is? Spark is a new distributed analytic engine that was, well, developed in UK University of Berkeley. Well, it's much simple and have to solve that kind of problem that Hadoop is hard to solve. And well, actually, here is an example. If you take a look at the performance, the Hadoop will be hundreds times slower than a Spark on some tasks, when you need to do a lot of iteration against the same data. For example, in this case, you see logistic regression performance. And you will see that Hadoop will read data for each iteration, process data, save it to the back to the HDFS, the fastest HDFS. And well, actually, the Spark will do it in memory, if it can. In any case, it can get most of the data to memory, process it, and put back, get next step. So you can see that Spark will be, well, much faster on a lot of. Well, actually, Cloudera claims that they're going to replace MapReduce with a Spark as a default engine. And so the MapReduce engine will die sooner or later. And well, actually, the other thing that Spark brings into this world of data analytics is simplicity. You can take a look at the, well, actually, if you know, Hadoop always say, see our first tutorial is word count. Let's count word in the system. And you, well, everybody who write MapReduce task know that what all these small lines mean in the Hadoop world. Well, actually, the Spark is 3 lines of code to do the same thing. We can go deeper into these lines of code later when I'll start talking about Spark in details. But Spark is really much simple to code. Well, in this case, it's Python, the Scala writing on Scala, or the Spark writing on Scala. So I recommend to use Scala, not a Python. But if you care about Scala, Python is another choice. Don't use Java. Well, and what this picture? Well, actually, I already talked about this picture. How the MapReduce work? Read data from the disk, map, reduce, write data to the disk. Read data from the disk, map, reduce, write data to the disk, and well, and so on and so far. Well, actually, the Spark build graph of execution and execute it on the data. So it's load data from given sources, get it if it can get it all in the memory, get it into the memory, or read it step by step, by partition by partition, read it into the memory. Do the map, joins, and all other things that need to be done. Cache the data at the moment they can fit into the memory. And do other transformation. So you don't do only just map reduce, but you do transformation over the data. And that also make code much more clear and improve performance, and really improve performance. And Spark IP. Well, actually, not only MapReduce, well, we need it, but not only MapReduce, but all other. It's not the full list, but you can see that all the useful API function is here. Group by, sorts, joins, all kind of joins. A lot of data sources I included into the already included or provided for Spark to get data from different sources. Cross joins, co-group, reduced by k, all other things, and then save data to the different different data sources again. So writing it back. So how it works? So the main data structure in the Spark is a resilient distributed data set, RDD. And well, actually, it can be covered by data frame that add names to the column or something like that. But inside the system, it's a distributed data set that contains of the partition of the data. Each partition contains a set of objects that can be processed by a map, reduce, and all other functions one by one in parallel. Or can be sorted and reduced and so on and so far. And there are kind of operation over that. Transformation or actions that get data to the storage or get data to your screen, print it on a screen, something like that. So there are two kind of function. One transform data, another one save them or print it to the screen. So when you get this U2 RDD, your RDD, define your RDD, you run as I say, the special graph. You define a special graph that run over the RDD. So all your function compiled and sent to all the nodes to run on the RDD. So you can see that we have two RDDs here and three stages of execution. RDD consists of partitions of the data that can be processed as one block of the data. And it's sent, say, we have RDDC that map to another RDD, that filter to another RDD, then join with RDD from other stages. Some of the partition of the RDD can be cached, and well, actually, the Spark decide by itself what he wants to cache, or you need to explicitly specify that you need this data to be cached, and then because you are going to use it once again, it's really important for any kind of dictionary you use in a process. So why you need to use Spark with Cassandra? The main thing because Cassandra doesn't have, and well, actually all new databases, or this kind of new SQL databases, don't have joins, group by, and all the things that you need to do reporting to the management. And well, actually all of the things that you need to do data mining, for example. Well, actually all of them include MapReduce, or kind of them. And Cassandra also have a producer, but as I said before, MapReduce is really small, really slow and not convenient to code. The other thing that why we need to use Cassandra with a Spark, because of that great driver that was built by DataStax, and I will talk about that a little bit, that allow it to map all the data from your Cassandra to the Spark and back with 2 lines of code. That's really important. Well, to have less code you have, less bug you have. You know, it's as I say, there is it's open sourced, so you can use it for free. Well, actually, we built our database platform that includes Spark and the driver and a lot of other security stuff. But you can use it for free. And a lot of people use Cassandra with, well, actually, the classical data flow that I see right now looks like Kafka, Spark, Cassandra, back to Spark, back to Cassandra, visualization, and your website. So it's a classical data flow. I see a lot of time and right at last time. So what the Cassandra Spark driver do? Expose Cassandra table as RDD. So with one command, like I will show you it, write data from a Cassandra in parallel. That's important. So if you collocate Spark nodes with Cassandra nodes, you will get data locality. You will get parallel writing and reading with into the local nodes, and driver know about the partitioning, about the Spark partitioning, and about the Cassandra sharding. So it's try to do everything with data locality in mind. It have automatic mapping of the Cassandra data tapes to the Spark and back. That's also really important. So all the data is supporting. Predicate push down is supported, so we don't get all the data into the memory, but all the filters that you write, not all, but most of the filters that can be afforded by Cassandra push down to the Cassandra, and we filter data on only that data that you really need for the analysis, so they can fit into the memory. Well, support Spark streaming, Scala, Java, Python. Well, actually, Python is supported through GPython in Spark, so it's always supported. And well, actually, connections look really simple. You just pass at least one node of the IP address of at least one node of the Cassandra. You pass the Spark Meister, and that's it. So when you start it, the next thing that we will do, we're ready to get access to the data. Let's do a simple example. Just create table and put data into it. Well, you can see SQL here, right? But it's not SQL, it's SQL. So you can do it with Cassandra. And well, actually, remember that SQL not a real SQL. It has some limitations, after all. So now, to get data from the Cassandra, you need to write only the first line in the second block. Cassandra, you describe, get data from Cassandra table. And all the data from the table, from the key-space test, and from the table words will be get into the RDD, and you can do all other things with it. In this case, we just print it, right? We get the action to array, and move data from the. Can you see the code on the list? So it's okay, right? Cool. Okay, so we can do the. So in this case, you get really simple thing, right? Without any filtering, without any MapReduce, we just print it for the. Well, and this is a Scala code, so don't be afraid about Scala. You can see the Scala code is really simple. Well, actually, when I do the talk, they say, "Oh, Scala, that's strange language. I write on the Java." I recommend not write on the Java with Java on because Java is too many words to do the simple things. Especially in this analytic side. Well, when you. I don't say that Java is bad. Java is good, but for the scripting, well, for the small scripting, don't use Java for the small scripting. Well, actually, Java 8 is much better. Lambda helps. Saving data is really simple again. It's only one command like save to Cassandra, and all the magic will happen inside the driver. In this case, well, let's see what the case do. I create an array, a sequence in this case, that contains two tuples, word and count, right? So I have two rows to put to the Cassandra in this case. The parallelize command from the Spark context in Spark allow me to make this array parallel. Its move do from array to RDD, so it become parallel. So if you want to do, if you have any small arrays that you need to join with a big data, you do something like that. You declare it, or read it from file, declare it, and do parallelize. And now we have for for line in our table. Type matching. Well, actually, it's for the reference. All types are mapped back and forth from Cassandra to Spark, from Spark to Cassandra, and well, you can get it. So it not need to be described. The next thing that is very interesting is that we can map tables to objects, and ORM are in place and work pretty, as usual, pretty simple. So let's say we have a table that describes car. We can create class that will describe the same thing, but in Scala. In this case, it's a case class. It's Scala objects that have some options for pattern matching and mapping, but the code is as is. And then you can do Cassandra table vehicle. This bracket means generics. It's not a generic in a Scala, but in Java world, it's like a generic. So I will get the RDD of vehicles, of the vehicle objects. So nothing else needs to be done for that kind of simple mapping. Well, actually, the struct, sets, arrays in an object also will be mapped into the struct, into the array set of the Scala world. So the complex data also mapped really simple. And well, actually, there is pluggable interface for mapper in any case. Predicate push down. Really important thing that I said before. If you need to select some data, only some set of fields, you can do. You can define the name of columns that you need to select. If you need to select row, you can also specify where. That will do filtering and filter only those columns that you need. Okay, so that was part about how to connect Cassandra with Spark, and now we can talk a little bit more about what libraries are provided on Spark. Yeah, questions? Yeah.
One of the things that the problem of NoSQL databases is that you are not allowed to do table scans, in the sense that is there done anything in the driver to kind of minimize the performance hit of reading so much data out of it?
Could you repeat the question? So what actually is the predicate push down when you do where?
My question is that usually when you have NoSQL databases, is that it's very hard to do a query and take out data, because that's a big performance hit. That's at least I'm a Mongo man, so that's where I come from.
Okay.
So Spark takes out a lot of data. So is there anything inside the driver that takes care of kind of taking out the data in a good way without killing performance?
Okay, the question was about bulk loading. Well, actually, all NoSQL data are not very good with getting bulk data out of the database. Well, actually, they all have k value thing inside the database, right? And if you want to get data fast, you drop k into the database and get the row out of the database, and that's all. Well, actually, all that kind of indexing and all other things that happened in any that kind of NoSQL database works like you query index, get k's, and then get all the row by k, right? And when you do filtering or something like that, you get all the row and just filter it one by one. And the question is how to do bulk loading. And what the driver do for the bulk loading. Well, actually, for bulk processing, everybody the idea is that what the driver do. Driver would get architecture of the row, of the cycle of the Cassandra nodes, and knows knows the shards, what data resides on which data resides on which Cassandra node. And you can decide, well, you get it really clearly by token ring ranges in the Cassandra world. Well, actually, in other databases do the same thing. I will talk about Cassandra because it's really simple to implement. So you know data ranges. Now, as you have a data locality, you can query the data from a particular Cassandra node in parallel, sending the, if you have the same node of the Spark on the same node, you can query only this range of keys that are reside to that Cassandra node. So you can get all the data in parallel from all the nodes. Yeah? And it's much more. So you don't do it through the you don't do it through the drivers, through the one point of access. You do it in parallel on each node locally. And then, well, after that filter, that ensures that your query from a Spark will hit only one data node of Cassandra. You also add the filtering. So the Cassandra will also apply this where and filter more data out of this range that it consists. So in a good way, in most cases, no network interaction happened. So every Spark node talk directly to its own Cassandra node and get data out of them. But this calculation of the ring ranges and so slow down start of the execution. So remember, it's when you talk about Spark, you talk about analytics, not about Spark streaming, but about Spark itself, about this batch processing. So right now we talk about batch processing when we load a lot of data, process it, and save results. It's not really fast because it needs time to calculate all the things, to optimize the graph execution, and well, all the optimization done, it starts processing fast and in bulk. Actually, it's a good time to answer some questions, and then I will start talk about Spark modulus. Questions? More questions from the audience?
Are you storing the data in a column format?
Yeah, sure. It's actually it's a column format. Well, actually it's
Parcels or?
Excuse me?
What's the data format?
Well, actually it's a kind of SS tables when you store the key, column name, and the value. So it's a wide row. So you store a wide row with a key and a value. And value contains column names, value of the column. Column names, value of the column. Well, actually, there are, in a Cassandra 3.0 will be introduced a new storage engine that will be better fit SQL.
Store columns, which answers his question, basically. What he wants to know is, can you load the columns directly? That's what he was asking.
Well, actually, you can roll. Well, actually, you always wrote columns directly, right?
Yeah, but you're cracking them out of the blob. You're not taking them as a contiguous column and loading them in.
Well, actually, all the thing happened under the hood, in a Cassandra engine.
Yeah, but so they have to crack them, so there's a performance problem.
Yeah, sure. But well, actually, when you do it in parallel, it's not. It become much less performance problem. Yeah, memory is not free, you know. The only important thing in a current world is that memory is too expensive. Disk is too slow, memory is too expensive, CPU is for free, right? Okay. More model. So right now we talk about the basic of the Spark. So the basic of the Spark is that RDD world and this execution graph processing machine. And based on this execution graph, we can the Spark provide more convenient interfaces. The first one is a Spark SQL. That will actually Hive compatible. So I hope everybody knows what the Hive is. It's a SQL engine in the Hadoop world. And well, actually, Spark SQL contains SQL query engine on top of the Spark. That, well, right now, in Spark.5 it's run comparable with the TES. But please, so if you need only TES or something like that, probably you can stay on with TES. But if you need other Spark thing like a like a caching, right now, I think right now Spark compatible with TES performance. It has all the Hive compatible thing like JDBC support, JDBC server support, UDF, type metadata, all other thing. But support Spark, support in-memory processing, so you can cache the table, and it will be stored in Spark RGD, and you will run it. So you can get fully in-memory database with the Spark SQL, but still analytic. Analytic Spark SQL. Don't expect milliseconds. So if you need milliseconds in response, you use Cassandra directly. If you need any fast engine, you can use Spark SQL. And well, actually, push down predicate to Cassandra. Well, not only to Cassandra, it supports most of the databases that have a predicate. You can push down predicate. And well, actually, example of use SQL context. To use Spark SQL, you need in a program. Well, the good way you can use it in a program, not only in a command line. So to use a Cassandra Spark SQL context, you just create Cassandra SQL context, and then use SQL to Hive compatible SQL. It's not SQL. In this case, it's SQL, the Hive SQL. SQL that allow you to do all the things with the databases. Not mentioned here, but well, if you like that kind of command line, like SQL shell, you can do it with SQL as well. You can run SQL shell. You can write JDBC server and connect it by JDBC by Hive JDBC driver and get all the data out of that. Most interesting part of the Spark and well in the data processing world right now is the Spark streaming. So data streaming is when you get data from a stream, from Kafka stream, for any others, process them on the fly and store results or show results to the user. Spark provide and well, actually, when everybody start talking about streaming, they start talking about Storm or something like Samza, and the first thing that you start to do in a Storm, for example, you start do data buffering, because you cannot write data one by one into any databases. You start buffering the data into the small data sets and then store it or process it in small batches. Spark goes another way. They start batching data for you at the beginning. So it put data into micro batches organized into small RDD, and so you don't get the stream of the events, but you get a stream of RDD. So you get a distributed stream that contains RDD that can be processed in parallel. So after that, you get after this optimization, you get back to the all these functions that you get in to work that we talked before. So you can do on a streaming world, you can do all the things like joining, like group by filtering, and so on so far. And let's see how it will how its API will looks like. In this case, we will read data out of the out of the socket, and then do the same word count example. We defined the stream, distributed stream, like lines, just by getting the streaming context and define the IP address when we will listen for the data. Then we will do all the same thing. We will map the data, map RDD to the stream by splitting it to the words, map words to the tuple word and number, and reduce by k by summing them. So we will get a dstream back. So the word count, it's also dstream. That will contain a group of data that will be produced once a second. If you can take a look at the first line, that will get it once a second. You will get the new RDD that will contain how much word you get this second, and to save it to the Cassandra is really simple. You just save to Cassandra, and you will get the new data in Cassandra each second. If you say it word count print, you will get the output once in a second. Yeah, sure.
In order to understand this example, is this something that then continues to run as long as there's data coming in?
Yeah, sure.
Just get run once?
No, it's continuously run. Well, actually, it's as expected, it's streaming. It's continuously run, and once a second, you get a result.
So, but if I look at my debugger, the await termination hangs there, it blocks until there's no more input to the stream.
Well, actually, yes, it will be blocks, and we'll wait till the new data come to the stream, and we'll just produce empty RDDs. If you don't get data in a second, you just get an empty RDD and wait for the next one. So each second you will get data. Well, actually, it's important difference, as I say, against other system. When you get event by event and process it event by event, in this case you get the time-bound block of the data per second. You can say per minute, and so on and so far. Well, actually, there are Windows functions that allow you to get every second last 30 minutes of the data. For example, you can get state, so you can get a dstream when you get the state and update state for each new event. But after all, well, actually, this streaming example, important thing that that way to do streaming is much more performance-wise, because you get buffering out of the box. And yeah.
But you lose the fact that you've got something important in the stream, you're essentially batching them, so you're pulling everything.
Yeah.
So if I've got a new stock price coming in and it's higher, I'm going to have to wait until that window, so I'm going to miss it, not be able to make it.
Yeah, sure. Well, actually, as I say, it's a different kind of. So if you're ready to wait for, say, 100 milliseconds, it's the smallest thing you can get. Probably 30 milliseconds you can get. The batch with 30 milliseconds and configurable. It's okay for you. But if you want React on event, you use another tool. Well, that's true. You use with Kafka you use Samza or Storm, something like that. In this case, you do it event by event. But well, actually, back to the Storm. The first thing that everybody wrote for Storm is a memory buffer to buffer data and write it in batches. Well, actually, I see it every time. Except stock prices, but no one do stock prices on Storm. Well, actually, stock prices done on a Linux kernel level, as I say it usually, because every microsecond means. All other things is much better when batched. Okay, next thing is machine learning. And this, well, probably the most scalable machine learning library I know. Well, actually, if you need the best machine learning libraries, you use R and all this and all the things. But unfortunately, R scalable not more than to the one machine. And well, actually, when someone say I use API with R, I want to see that people. No one use it. Well, usually you have mathematicians who do R scripting on its own small data set, and then you have a Java developer who do it on MapReduce, the same thing. Spark spent a lot of time for developing scalable algorithms. It's still really small set of algorithms from the R point of view. But for the practical usage, they have all you need. They have classification algorithm, basic one, a little bit clustering, all set of linear regression. Recommendation engine can be built on the collaborative filtering. What we have is the time. Okay, I have 20 minutes, so we have time to talk about them. This is my lovely part. I can talk about it for a long time. Dimension reduction, frequently pattern mapping, and well, actually, they implement work to vec. Yep.
What do you mean by the algorithms work in a distributed way, and you can scale them across the Spark cluster? I was trying to work with work to vector, and I found out that I have too many data in the last step. There's quite a huge matrix that actually sends everything to one node, and if this one node is limited by RAM, you cannot process it. So can you elaborate?
Well, actually, you select a bad example. Word to vec is not best implementation here, and well, actually, I also was surprised. Well, actually, I also was surprised that that the last step is executed on the one machine, but this is how the word to vec work, unfortunately. And I hope they will. Well, there are only two implementations of word to vec in the world, right? The native one and this one. So it's not this particular implementation is not perfect one, but
because I'm wondering if you promote like distributed machine learning algorithms, this one should not be on the list. Today, it's not possible to do this distributed.
Well, actually, they do everything except the last step, distributed. Well, actually, for a lot of machine learning, well, actually, to scale machine learning algorithms is not a simple thing. And well, actually, and some of that algorithms are up there also have that kind of the last step, but it's still faster than one step algorithm. Well, it's the hardest and most interesting part of the Spark and of the current world today, as previous presenter told us. So I will not show you a word to vec example. Let's see how the classical classificational problem can be solved with a Spark machine learning algorithm. I will solve one of that problem that we'll see on previous in a previous presentation. In this case, we will do select understanding what type of areas we see. So there is a classical data set for machine learning examples that use irises and 4 measures of this flower. And let's teach our algorithm to understand what flower he can see. So what we will do, we'll read our data set out of the Cassandra, prepare the data, and this is, well, always the longest, well, the hardest thing always is to prepare data. In this case, algorithm expects that we will get label it point. So we need a features, set of arrays of features, and the label. In this case, the label will be the name of the species of the flower. The other two steps are really well. Actually, I skip a lot of machine learning steps here, and well, we can talk about them out of this discussion. So the simple step is train the algorithm. In this case, it's naive Bayes, one of the multi-classification algorithm, and then we can get model out of that, and then we can do just ask the model, I have that kind of measurement, what the flowers it is, and to do that I need to say predict, and the system will say it's that kind of flower. So it's look really simple at this point of view. Well, in the latest Spark, they introduced Spark ML that allow it to build more professionally looking machine learning pipeline. So they allow to build pipelines with data preparation, cross-validation, and getting results. But the simplest way you can do it, well, as you can see, machine learning is really simple. 5 lines of code. Yeah, questions?
That's another thing, like for a practical approach, you often want to have your model, train it, evaluate all the things that you just told us, and then you want to apply it. And I was wondering how you do it, like in the analytic way, to like how you deploy your model and then have it as a service running, like in real time. Kind of stuff.
Okay, well, actually, to deploy this, you can save model. The model can be saved, so the model save. Then you can load on the system and call predict if you run in Scala. If you're not running on Scala as usual, you can save it into XML/ML. They support that some kind of standard. Load it, fix all the problems with XML/ML because it's not really compatible, interoperable. Yeah.
Yeah, but like when we save the model now, with our setup now, we would store it in Cassandra and then load it and get our RDT model representation. I'm wondering how you set up a service within Spark. Like you're still in Spark, you're still on the RDT. How do you like serve that?
Good question. Well, as I said before, if you want to do that kind of servlet-based, I recommend to save it into the XML and apply it by another function. So, actually, to learn to teach the model, you need a lot of power, and you do it in parallel. To go back to apply model, you don't need such kind of power. You need to get it's hundreds of parameters usually. Well, actually, if you talk about linear regression, you get just equation, and linear equations that's really simple to apply to any system by hands. So in this case, you will get really you usually use save model and apply it in production by another code, not in a Spark environment at all. Or if you need a batch prediction, you do it in Spark, save it back to the databases, and get. For example, recommendation is usually done in batch in a Spark. So we do recommendation for the all users, save the batch to the Cassandra table, and then fetch it. Okay. 10 minutes till lunch. Let's be patient. Okay, let me stop here. What did I miss here is, as I say, Spark ML. That's in an alpha stage, and Graph. They also have a Graph engine that allowed, and a lot of people try to use it. It's still in a alpha stage, and actually, someone says that's good. Other ones say a lot of out-of-memory exceptions. So I will not talk about that because I don't have. Well, it needs a lot of time to go into the graph algorithm before I can show you a simple API that implement that graph algorithm. I'm sorry. And well, because everybody talk about page rank that's not applicable in a real world. Only Google use page rank. Sorry, guys. Let's go. Okay. Algorithms, as I say, API. You can use Scala, and I recommend to use it as a native. Python. Python is a good one. Well, and all examples I see about machine learning is on Python. But it's GPython, so don't expect a lot. It's a Python inside. Java. There is a Java. Well, actually, you can use Java, but it's look ugly. Especially if you don't use lambdas. So Java, I recommend Java 8 only. And well, actually, they introduced R interfaces, but no closures. Only Spark SQL, actually. So you cannot do R algorithm in parallel. You get the R. You get only the data in and out. Questions? Well, actually, what we have done? I get our architecture and put Cassandra and Spark on it. And you can see that you can do streaming with Spark and get speed layer with Spark and Cassandra. You definitely could use Cassandra as a serving layer, especially if you have a lot of users and a lot of, well, stuff to store. And you can use Spark and, well, probably yet Hadoop, especially if you use HDFS to store your data lake data in master data sets. More questions?
Yeah. Would you still recommend to have HDFS in the stack for like coding, like have all the benefits of the security of the HDFS, or also there's this one thing that if it's HDFS stores the sequence files, then you can make it so that it's still ASCII readable. So in case of a complete outage, you can collect manually all the files and it's like text encoded, which is not possible with Cassandra. And so how do you stand with Hadoop and HDFS? Like, what would you recommend?
Well, actually, Hadoop is the only way to store petabytes of data. And well, actually, and if you want to process data sequentially, Hadoop is still very good. And well, not Hadoop, but HDFS. So if you want Spark to process data sequentially, and you have a petabytes or gigabytes of data that you just need to just go through all the data you have, like logs, files, it's still something like HDFS. So remember that all this Cassandra is for the random access data. So when you store everything sequentially, for example, but you need get only 5% of the data selected wisely or something like that. But if you need to store petabyte of data, or if you want to store everything I have, you still will use HDFS, not the Hadoop, but HDFS as a part of the Hadoop. But then you can run Spark on it, not a MapReduce, something like that. Well, the other question was what the data format you use for that? Well, actually, it depends. After that, it depends. More questions? I think, well, any questions from the internet? No. Okay, we have 5 minutes still, so we can run a little bit.
But it's okay if there are no questions.
Yeah. Okay, so thank you very much. Don't forget to use this one tool for me.